Hi everyone. Welcome to Tuesday of week 3. For those that are joining live, it's nice to see everyone. As always, I'm amazed we've managed to get 74 people to wake up for 10 a.m., which is super exciting. So today we have 3 key topics to go through. Just before we do that though, I think I wanted to very quickly address a common question that we've been having on the forum, which is just surrounding the actual running of some Python code. So this is going to be very quick, but essentially, like if you've got your project wherever I put it in the main directory. If you've got your project right, you know that inside the source folder you have a bunch of files, and inside the test folder you've got a bunch of files, and you also know that if you want to run a file like a test file like echo test, then you can just run test echo test and it will run. Some people have been having problems though running, say, source/echo, which is if you want to run the actual Python file directly. Now print hello. Now I'm not like a Python expert because I don't work with this every single day. Python's something I've spent maybe a couple of years working with, but not anything extensive. But in some cases, and I can't remember why off the top of my head, I'm sure someone who's bashed their head against the wall knows, is that Python doesn't like you invoking scripts which have imports directly on command line like this. Sometimes what it wants you to do is actually run them like a module instead. And what that means is that rather than running Python 3 and giving it a Python file, like source/echo, you actually run Python like a module. We can run PyTest like a module, we can run other Python items like a module. You can actually run your own code like this. So these 2 lines here, which are, the first one is actually giving you a Python source file. The second one is saying to Python, I'd like you to run a module, kind of like you're importing it, right? Like I'm importing source.echo, and I want you to run that as a module in Python, a little bit like PyTest. This will also work. I'll be honest with you, I don't really understand why this works for me here, and it doesn't work for some other people. We haven't really run into this before because we haven't done the file structure like this, so it's a bit new for me, but point is that if you can't seem to run your Python file because you get an error that's like, oh, can't find module source, then try running it like a module is probably the best advice I have. Further to that, in the actual ed forum itself, I don't know if I can log in here. Okay. In the ed forum itself, if I see a post that someone makes that I think, damn, everyone's going to want to know about this, or like a lot of people are, I should say, I will just pin it. So if you actually look at the top of ed, there's a bunch of pinned posts, and those pinned posts are ones that I pin because I'm like, oh, that's probably going to be a relatively common question. So I'm pretty sure I've pinned a post that a student raised an issue with this, and we addressed it. So anyway, that's just a little bit of pretext. We're going to get into these 3 lectures today. Hopefully we'll spend the first hour on this one and the second hour on these 2. And this one's a fun lecture, and I don't mean fun in the sense that you're all going to cheer. I mean fun in the sense that it's good for you, which is the best kind of fun. I think it's an interesting lecture, and it's really actually it's really the first time I think many of you will have ever actually had a lecture on testing in more a sense than testing as just writing if statements and doing stuff to make sure your code works. But let's actually get behind some of the theory of it. I think this is really cool because some of the theory in lectures like this I use every day to help explain things to colleagues and employees in the world of testing. There is 2 big words that I want you to remember. One is verification and the other is validation. Both are relevant in this course, though verification is a more relevant concept to what we're doing in 1531. And just to read this out, right? Like verification is set of activities that compares a product against the required characteristics. Right? So we know that from the software development lifecycle that you define requirements, you specify what the system's going to do. You could think of the interface like that. You could think of like what UNSW Dreams needs to do. You specify what defines success. Verification is the process where you compare the product, basically the thing you've coded, against those requirements. And you're kind of already doing this already, right? Because when you write PyTests, what you write PyTests against is the required behavior of the application, right? You read the interface. You're like, okay, well, it has to do this. It has to fail under these conditions. If it succeeds, this is what it gives me. Like the requirements are already done for you, and your tests are actually you doing verification. Right, you're comparing the product, i.e. your implementation that you've either written or have yet to write, against the requirements, which in this case is expressed through PyTest, right? So requirements, your code, and PyTest is the verification process through that. Validation, on the other hand, is a set of activities ensuring that a system but it basically accomplishes its intended use and goals. And what we mean by that is that you might effectively write PyTests that prove that your implementation does what the interface or requirements do. But does that actually mean the software does what it's intended to do and makes people feel how it's intended to make them feel? Like when you give it to real people, will they use it? Does it solve their problems? And this can be bubbled down to a concept that I want you to remember here, which is verification is trying to ensure that the system is built right, and validation is trying to make sure that the right system has been built. Okay, and to kind of give you an example of this, it's like if someone says to me, "Hey Hayden, I need a transport vehicle where I can carry 100 kilos," right? Like maybe they have like a couple of big suitcases. Verification is like you might sit down with that and draw out the requirements and be like blah blah blah. It needs to be right. It needs to be usable by many people. It needs to have this kind of range. Blah blah blah. And the implementation you might come up with might be a bicycle with a giant tray on the back, right? Like a souped up Deliveroo Uber Eats bicycle, and on that bicycle, it might satisfy all the requirements, which were it needs to carry this much weight, it needs to be this mobile, it needs to be able to go this far, it needs to be usable by someone without a special license, right? Like, you might actually have, if they're the requirements that you ended up with, then you might have actually built that system right, because everything you did actually satisfies those requirements, right? So this is the PyTest analogy. And in that case, you've actually built the system right, because you had a set of requirements, you built it, it satisfied the requirements, it's been built right. But on the flip side, you have validation, which is saying, was the right thing built? And what this is really getting at a little bit more, it's a bit more complicated, but it's in some way testing the requirements and kind of sanity checking things. So validation is actually what, if you were building a software app, verification is something you'd be a little bit more concerned with as a software engineer, and validation is something you'd be a little bit more concerned with as a product manager or a UX designer, because you could actually define a system, build it correctly without any bugs, but then when you actually give it to someone to use, they're like, yeah, this isn't really what I want. I was expecting something with a roof and 4 seats and a car. They were like, thought I was going to get a car of some sort. So even though we built that bicycle right, according to our specification, it wasn't the right thing to build. And that's validation. We do a little bit of validation in this course, not a ton. A lot of what we do is verification. Validation would be if the course was a lot heavier on setting requirements and doing user interviews, which I think there's more scope for it at CSE to do, though I think we get somewhat close to that in COMP1511, which is human-computer interaction, though I think we could do more. Okay, now types of verification. So this is the first one, making sure that the system has been built right. Formal verification is one type of verification. So now we're really getting into that category of what types of testing exist, right? Because if you think of verification like testing, it makes a bit more sense. And what types of testing actually exist. The most kind of fundamental type of testing is what we call formal verification. And formal verification is actually kind of, what you do is you treat software like a mathematical object that you can reason about. So it's kind of like testing. I don't want to call it testing code by hand, but it's essentially, you could imagine if you took a bunch of your source code and you reduced it down to a bit of a mathematical expression, you could essentially do a theorem proof on it, as one way to think about it. So if you remember first year maths where they're like, prove that this, you can actually do the same thing for code. Because if you can reduce code to math, then you can prove something in math, and you can actually mathematically prove that software is that works. Like a good example, I'm trying to think. Like, I've never done anything to do with formal methods. I've talked to people who have, but you kind of have to ask yourself. It's like, okay, well, if I have a variable that's like a is equal to 5, and I check as a, a is equal to input or int input. If a is greater than 5, I'm not writing Python here. If a is greater than 5 and a is less than 10, print success. Right? Now, this code here is bug-free. In the sense, like, assuming an input is a valid int is entered, this code is bug-free. Right? Like, how do you know that? Well, I mean, it's so simple that you can look at it and you're like, oh, well, that's clearly bug-free. But you could imagine if the code was bigger, that it's a lot harder to just like look at it and reason about it. So when you look at this code and you think, oh, it's bug-free, you're doing what we call reasoning about it. You're not testing it with PyTest or something. You're kind of looking at it and you're trying to logically deduce, yeah, well, it can only be between 5 and 10. That's all that can happen, So, but formal verification takes this like wildly further. I think there's a course on it in CSE. Maybe there's not anymore, but maybe it's probably still there. But you can go check that out. It's super interesting. Cell 4, there's a group at UNSW called Data61 who look after tons of these microkernels and stuff. They're really well known a group because from memory, and I mean, again, this isn't my area. Normally an operating system, I think, is like 1 million lines of code. I think I was told once, like Windows or something might be like 1 million lines of code. But they were trying to build like a mini operating system that was like something like 10,000 lines of code. And the reason they did that was to make it small enough to be able to apply formal methods on it, to actually verify it this way. Which way? Where's the sides? Yeah, to verify it this way. So the idea was they made a mini operating system that was small enough to verify formally, and then they verified it formally, which was very painstaking, but because it was a very small operating system, it was feasible. And therefore it kind of built itself a reputation of being essentially like the world's safest or most reliable microkernel. Because the funny thing is, and this kind of comes back to tests, which we're going to talk about in a sec, which is that testing shows the absence. Testing shows the presence of bugs, not the absence of bugs. And that's the appeal for some people with formal verification, is that you can actually, go through it and prove that it's correct. And again, above my head, but an interesting area, particularly if there are people here who are quite interested in maths. That's something you might find interesting. It's extremely expensive to do because it's like painstaking. That's why they needed to make the microkernel quite small. But yeah, you can see that to do 10,000 lines of C, to verify it formally, it took them, I don't need a calculator for this, Jesus. 500 lines of code took a year. So I don't know what a person year is. it could even be 365 days of a year. But if you assume that someone spends 200 and I don't know how many days people work in a year. Let's just call it 250 days in the year times by 8 hours. That means that, unless I just messed that up, that means that like every line of code someone spent roughly 4 hours on average trying to formally verify it. Downside, that's a bit weird, crazy, right? Like insane that like that amount of time can be invested into something. Good part though is that it works. Catherine says, is this stuff that hard when it is practically used? Doc years are shorter. I genuinely don't know a lot about it. I understand it conceptually enough to know that if you can represent your code not as a bunch of ASCII, but as a, think of it like a flowchart, right? Like if you converted your code to a flowchart is maybe like one analogous conceptual thing, then you can think about it differently. Right, it's kind of a similar thing, except you're doing it in a world of formal methods of mathematics. So that's formal verification, but that's not the kind of verification that we're going to be doing. We're going to be doing normal person's verification, which is just writing tests, which is what basically everyone does. And it's because it's better than 4 hours per line of code or whatever the number is in reality. So as we said before, testing shows the presence, not the absence of bugs. So you test not to prove that your code works, but to look for bugs. And if you find bugs, it's like found a bug. But if you don't find bugs, they might still be there. Right? So this is kind of the conundrum of testing generally, is that when you're not using formal methods, which you pretty much never will, you maybe have 1,000 things that can go wrong in your code, and your job with your tests is to try and cover all of those potential areas where there might be bugs. And you're going to miss some. You're always going to miss some. There are bugs found all the time in the largest pieces of software. Praf says, is it expensive because of the time and detail it takes? Yes. It's like manually. Yeah, it's just a. So Ayash asked a question which I probably just completely glanced over, which is, so is formal verification done by a person or a computer? It's done by a person. Again, it's like literally like the closest thing I can give you if you don't understand it is just like when you get asked to prove something in a maths course. They're like, prove that this is true, and you like do this, do that, and you're like, yep, it's proven. It's the same kind of thing. You do that by hand, but it's to do with code. Okay, so there's 4 types of normal testing, right? This is like testing with code now. So formal methods was something interesting. This is all testing with code. And those 4 types of tests are unit tests, integration tests, system tests, and acceptance testing, right? Now, the problem with these definitions is that they're very broad and they can mean different things in different languages. So I want you to take all of this with a grain of salt, because what I don't want you to do is get into a workplace in 2 years and be like, oh, I remember in that 1531 lecture on the 22nd of March 2021, we talked about how unit tests are strictly white box tests. That's not really what this is about. We're just trying to explain that there's kind of different levels of tests and the abstraction surrounding them. So the first type of test is, and I'm going to relate this to your project, because if I don't do that, it's not going to be concrete enough. Though again, it's a bit of a loose association. So unit tests are essentially when you write tests on functions. Okay, like if you think about code, you have, at the smallest level, you have a function. Nothing can really be smaller than a function, right? Like the only thing that can be smaller than a function is a Python file that isn't a function. But you wouldn't ever really want to write code like that in reality, right? So a function's kind of the smallest thing you can feasibly write a lot of the time. And a unit test is exactly what it sounds like. Like, what's a unit? A unit is An individual thing or person. Okay. So an individual thing or person. So a unit test means testing like the most atomic individual software component, which is typically a function. So sometimes you will write one function and then you will unit test that function. And what that means is you are writing PyTests for that one function. Not all the other functions. This is not really what you're doing a lot of the time in your work for the project. In fact, like the only thing I think anyone here might be unit testing might be register technically, because you can test register in isolation, sort of, but yeah. So unit testing is just testing a single function. We'll go back to the project once we go through all four of these. Integration testing, though, is short answer where you are testing how multiple units work together. And this is a lot closer to what you're actually doing with the project. See here how it says like expose defects in the interfaces and interactions between them. So what's a good example of this? Well, if I register a user and then I try and log in with that user, that's a kind of integration test in a way, because I'm not, like a unit test would just be testing auth register. A unit test might be testing just auth login, but the way that integration testing works is that you're kind of testing how they work together. So you might call auth register and then you might call auth login after. So I'm going to register a user that I'm going to try and log in with that user, and if I can successfully log in, that means they kind of work together, and if I can't log in, that means that they're not working together, right? So there's a defect somewhere there in the process. So integration testing is integrating units, might be a way to think about it, where units are individual functions or classes or something like that. System testing, this one is the hardest one to talk about because for small projects like the ones you're doing, the difference between system testing and integration testing becomes quite small. In terms of, I would struggle to adequately distinguish these two for you. You can see that the definition here is the process of testing an integrated system to verify that it meets specified requirements. Now, what that means is that integration testing might be testing that specific, functions work together, right? Register and login, whereas system testing might actually be testing a broader concept, which is like that a user is able to register, log in and log out multiple times, right? It's a bit more high level. Now, typically what might happen is that in a normal project, you would actually have a much broader set of requirements up the top. And those requirements would kind of look like, things like, where's the README? They would kind of look like things like this, right? Now, because of the highly strict approach that we're asking you all to take, like implement this interface. Like normally what would happen in a project is that you would come up with requirements yourself, and then you would go and write an interface, okay? Like you would write the interface. And what a system test might do is a system test might actually test if these things are true, right? Like, can someone reset their password? Can someone view a list of channels on the application? You know, these like higher level things. Whereas an integration test might be testing, for instance, that particular units or parts of the interface actually work together. So what I'm really saying here is that for your project at this stage, at the very least, integration tests and system tests can be conflated a little bit. In terms of system tests are not really too much a thing you would be doing. Like most of what you're going to be doing in the project is integration tests. But system tests just test that level above, right? Because a user, like the system is not auth register and auth login, right? The system is a higher level thing where it's like, oh, well, can we register and log in? and maybe that happens on the front end or something like this. So system testing, think about that as just not just testing units together, broader concept, and then acceptance testing, which is the last one. So acceptance testing is formal testing with respect to user needs and business processes. And in reality, this is often called user acceptance testing or UAT. What that actually refers to are users physically using your system, right? So unit tests, functions, integration tests, integrating functions, system tests are testing the broad requirements, and all three of these things tend to be done by people like you, either the developers or testers or test engineers, but people with an engineering background. And acceptance testing is typically done by actual customers themselves. So people have asked, like, what's white box and black box testing? So the specification talks about black box testing, and it kind of explains what that is, but we don't really talk about white box testing in the spec. So I'll quickly give you a bit of a contrast with these things, and maybe we'll do it just by modifying... it's the wrong thing. HDSQ has asked a good question, which is like, hang on, so were we supposed to do a bit of all those tests? So, no, is the short answer. Acceptance tests you can't do because you don't have any users and you have no actual product to use. System tests you can't really do because your product's so small, and you kind of would probably need more of a... Yeah, it's a bit too small to separate these two things, especially since you're not working on the front end. Which means that at the stage you're at, right, with this small set of functions, the only two things you can feasibly do are unit tests and integration tests. Now again, these terms are very broad, but in the sense of these slides, we're describing unit tests as white box tests, and we're describing integration tests as, usually black box, but they can be white box. And integration tests are basically what you're writing in your project, because it's very hard to write black box unit tests, though in some cases you'll kind of have done this. And integration tests are testing how different units or functions actually work together. So basically, in summary, in the project, so I was just reading a comment. In the project, you're generally writing integration unit tests that are all black box. Okay, and we're going to talk about white box and black box here. So Max has said the spec says black box unit tests, so isn't there a contradiction here? How can you unit test and stay a black box? You can unit test and stay a black box. You can integration test and use white box, right? So I just to be really clear, these kinds of two questions about like unit test v integration test and white box v black box, these are two separate concepts. They're not like intrinsically linked together. Like it's not like a unit test. This here really should say usual method or like common method as white box. But there are black box unit tests. There are white box integration tests. It really depends on what you're trying to achieve. And also the problem is that some people interpret unit tests as like testing a couple of functions together. Because in software it's never quite that simple as just, there's just one function. Because a function will call another function which will call another function. So if you write a function that actually has two helper functions, right? Like if your auth register here actually calls helper 1 a function and it calls helper 2, it's like it becomes a little less clear about, is this a unit test if you just test auth register? Because, well, it's kind of using two other functions. So is it kind of an integration test because it's like how functions connect together? Like maybe. So it's a very vague area, but we're just more trying to establish the idea that what you would label things, right, is you generally describe unit tests as something where you're testing individual software components, and you generally describe integration tests as when you're interacting between different software components. So for instance, some people might call testing register and login together a unit test of like that particular feature, but when you're actually like registering and logging in, and then you're integrating that with channels, for instance, then that might be integration testing. So sadly, there's not a clear specific Python definition, because it would vary depending on teams and projects and some other opinions, right? Software engineering can be a really opinionated place. But yeah, so integration, unit tests, these I'm giving names to things that you're already doing, right? Is in, we're not doing anything here that we're like, wow, you need to write this whole type of test that we've never told you about, because we've just asked you to write tests for your code to make sure it works and make sure they're black box. We're just giving names to it. Your tutor's not going to be like, can you show me your unit tests and can you show me your integration tests? They're going to be like, show me your tests. And we're giving you names so that you can start to understand what you're doing better. You can start to categorize it and bucket it. So what I want to talk about very quickly is unit tests and black box and white box. One of the problems with this content too is that the courses that students have done prior to 1531, some of the content has changed, and therefore it's a little bit unclear to us, and we're going to try and figure out the answer to that as to what extent you're familiar with any of these concepts. Because, for instance, when we kind of first wrote this, students had already been really emphasized the difference between these two things. So in our spec, we just used to write, your test should be black box tests. And then we added more stuff, here to actually help students along. But let's just talk about white box tests. So white box tests, echo test and echo. Now I'm just going to use these two files because they're here and they work, but let's just get rid of, let's just do register and login here. So inside of my echo, why don't we just use the actual register and login? Okay, so let's keep it simple. I've got some data object that's going to be I might call this one users, right? Users is a dictionary. And when someone tries to register, what I'm going to do is I'm going to say users of that email address type have a password of password, and they have a name first of that and a name last of this. Right, and then what we will return is we'll return email. I think actually no, they just want to return the auth user ID, don't they? Okay, so we need like a user ID of some sort. Auth user ID, and this can be, let's just say this is some number that's like generated 3, right? In reality, you're going to have to generate that. And then the function wants us to return an auth user ID of 3, and I might make this a variable too while I'm here, which is 3, and then I'll actually return auth user ID here, like that. Now I think that should work. Great. Now, this is what happens, like a user email is actually added here. So if I was to say here, just try and print users, I'll just put this here to simplify that for now. If I was to try and print users in say auth test, right? So I'm going to make a file now called auth-test.py. And from auth test, I'm going to, from source.auth, I'm going to import auth login v1 and auth register v1, like this. And then I'm going to have a function here called test register, and let's see how that one goes. So test register, I would call auth register v1, and I would pass in Hayden at unsw.edu.au, 1234 as a password, and Hayden Smith, like that. And then we can just try and run this. Keep it simple, test/auth test. Seems to pass. What does it actually return? Auth user ID equals let me make these spaces, and I expect auth. So here's the kind of mistake that people Yeah, I know it's not a valid password. Sorry. Okay. Here's the mistake that people kind of make. People start saying, oh, okay, well, to test this, what I'm actually going to do is I'm going to... let me get rid of this file. Yeah, I'm going to populate this with some stuff. I'm going to be like, yeah, well, user, Hayden at cactus.dog has an auth user ID of something like 2, and they have, whatever this stuff is. So I'm actually basically giving you a bit of free answers here. Like normally we would just expect students to, we wouldn't tell students like, here's how you write a test. So if you're trying to test auth login, right, your gut reaction might be, oh, so what I'll do is I will just create some data like this, and then inside of my auth test, I'm going to go test login like that, and I will simply say auth user ID equals auth login v1, and I want to log in with Hayden at cactus.dog and password 1234567 Okay, and I might word wrap these because you're probably dying. Yep, and then I test that, and then what I say is I'm going to go assert that auth user ID equals 2. And I run those tests. And I have some invalid syntax because I can't write code. Okay, and you're like, oh, well, does this fail? It says that the auth user ID returned is actually 1. Oh, well, that makes sense because, like, I haven't actually implemented this. So, I quickly implement this. I say, like, for key in users if key, which is kind of the email. If email, if data email, right? If the key in my dictionary is equal to email, then what I want to do is return the auth user ID of that particular dictionary key, right? Users, data email, that. Right, and this is something that most of you have probably done already, where it's like, okay, well, yeah, I have this data object, I loop through it, I look for something, you might have structured this differently, and then I return the user ID here, and it, like, doesn't quite work because you've probably also done something like this, where you're like, my auth login returns me some kind of data, and I'm checking if the auth user ID key on that dictionary is equal to 2, and then I should pass. And you're like, okay, good. Now, a couple of tropes that students fall into when it comes to testing. The first one is you shouldn't be testing on dummy data because the dummy data is not representative of the actual system. It's just you making stuff up. And what I mean by that is that let me take a step back. I don't want to come at this from a big conceptual philosophical point of view. So I'm just going to give you 2 really straightforward tips to help you not write bad tests. The first one is, when you actually run your tests, this should probably be empty, right? That's kind of tip number 1. It doesn't quite have to be empty. Some of you might have something like, that your data is like users, which has like this, and, your channels is like this. So when I say empty, I don't mean literally empty. I just mean you shouldn't have any real data in there, right? You shouldn't have any real data in there. That's tip 1. I'll just write this up here. You shouldn't have no data entered into your, I'll call it a data store, whatever you want to call these objects. Some of you have stored this in a separate file called data.py. That's perfectly fine. The second tip I'm going to give you is that you should never access your data store directly in your tests. Okay, this is probably the main trope that people fall into when it comes to failing to use black box testing correctly, right? So black box testing says that black box testing is testing the interface and not the implementation. What that means is that if your implementation changes, your test should still work. Because if your tests are testing the implementation and your implementation changes, your test will break, which is bad, right? But if your tests are just testing the interface, then you can change your implementation, right? So this is one of the cornerstones of abstraction. What does it actually mean to test the interface, though? Well, this is why I'm giving you this second rule or tip here, which is like, you should never access the data store directly. And what I mean by that is, okay, this is what someone will do here. They will say from source.auth, I'd also like to import users, which is this variable here. And their test login or test register, for instance, they will call auth register, and then they will say, oh yeah, I want to check that users at haydensmith.whatever exists. Right, like that users is not none. Maybe that's a way to do it. So let's say this is not implemented correctly. Let's say that this actually it's the wrong language, I'm sorry. Let's say that this function here for now just returns auth user ID of 1, right? Like a stub. You might run your tests and they both fail. Yeah, well, the first one fails, right? Because as you can see here, it tried to assert that inside of our users object here, that there was actually an email address called Hayden@UNSW. That's what you expect, right? If you register a user with that email, you expect it to be in the data. Yeah. So we're asserting that that dictionary key is not none, checking that it's in there. You could take that further, obviously, and like assert that, it's not none, and then you could assert that that this has a password of 1 2 3 4 5 6 7, like that. Like this is kind of what you're doing. Here's the problem though. You're violating that second rule we mentioned, which is that you should never access your data store directly, which is your users. So all of the data that you get when you're black box testing can't come from the implementation. It can't come from implementation specific details. So what that means is if I want to test if register worked, what I would actually do is as soon as I register a user, I would attempt to log in that same user with that same password, and I would expect it to succeed. Right, now if we could just like start here, for instance, and I'll take that even a step further, I'll actually expect that their two user IDs are the same. So now the one assert I'll do is that their two user IDs are the same. Like that. Now you notice here, I'm not testing any implementation. There's like, it's completely implementation independent. I have no idea how these are implemented because everything I'm doing is based on the spec. And this is actually one of the reasons that we ask you to write your tests before your implementation. Because if you write your tests before your implementation, it's actually impossible not to write black box tests. Right? As in it's impossible not to do number 2. In fact, it should be impossible to do number 1 as well. Gira Chan says like it's impossible to perform unit tests. Some people would call this a unit test, right? This is kind of why I don't want people to come away from this being like, oh, this says unit test, integration test, but the spec says this. Like, we're not getting into that right now, right? Like iteration 1's just being like write some tests. Unit tests are just another way that people mean write tests, right? Simple tests, right? Unit tests would often be called as simple focused tests that aren't like trying to set up an entire system and like connect with the front end or anything like that. So this lecture is really just trying to expand your understanding of like what unit test isn't just the only way to test, the only way to describe testing. But back to this. So Catherine and someone else asked before that. I mean, yes. So in general, you do also probably need to do this, which is to call clear v1 here. Now the reason for that is because if you structure your black box test correctly, most of your tests are going to start with auth register, and in general, it's really helpful for you. You don't have to do it, I don't think, but it's like it's going to make your life substantially easier to test. And cleaner, and it's better design and all of that because it's more decoupled. Is at the start of every test you want to clear your data so that you can like register from scratch again, because otherwise you're not really like testing. And this kind of comes back to like people said like, oh, so I thought we were writing unit tests, and you said that unit tests are only testing on a single function. It's like, again, you're testing individual software components, which is a broad term. So one thing that also can make these more like a unit test is the fact that if you're clearing your data every single time, then each test is isolated. It's an extremely isolated test. Whereas there are a lot of forms of system testing where like a system test will actually kind of test, it'll run dozens and dozens of tests off the same kind of flow and experience. Like once a user's registered here, the rest of all the tests are relying on that previous data. So this is a little bit more unitized. My VLab froze for a bit. Yeah, so this is kind of how you would write a black box test. You notice here I'm not using the user's object. I'm not using anything implementation specific. The implementation could fundamentally change and I would be fine. Yeah. Sorry, just Griffin, I know Joshua just answered. So for channels, for example, should we not try and rely on the auth functions to write our tests? I'm finding it. No, you should rely on the auth functions. So exactly. So pretty much it's like to test channels create, you're going to have a user that exists. So to create a user, you're going to have to register a user and so forth. So yeah, it's actually not that, it's actually really easy to do this if you follow those two rules that I mentioned. You know, which is like, sorry, VLab's absolutely crapped its pants. Which auth.by was, you know, don't pre-populate data objects with dummy data, and don't write tests that rely on implement, whatever I said, I've forgotten already. Tavarisha said you could use PyText fixtures to create a new user before each test. Exactly. That's why we mentioned PyTest fixtures in week one. They're a great way to keep your code nice and concise. So I need to create a user and his database. Yeah, so a good way to think about it is like you have to set up your test, right? You can't just like you can't just test. It makes no sense to just randomly call channels create with a number like that, because you don't even know if this is if this was like auth user ID. Because how do you even know 3 is valid? Like, you're actually assuming things about the implementation, even though it feels like, oh, I'm not doing anything with the implementation because I haven't written it. You don't even know what a user ID is, right? Like it could be like 3 might not even be a valid user ID based on the implementation. You know, user IDs might have to be at least 7 digits. So that is why we avoid implementation when we write black box tests, and that's also why we get you to write tests before your implementation as well. A few people have asked, how can you test clear, or is it implicitly tested through other tests? The problem with the way PyTest runs is that when PyTest tests, say like 10 test functions, it spools up your code once, right? It doesn't like run a test function and shut down and start again. It spools it up once, and then it calls your test, and then it calls the next test. So what that means is that if all those tests are kind of accessing the same data variable or the same underlying user's data store or data, whatever you will, then each test is just going to build upon that data, and that's going to make it really hard to test. It's going to make your tests brittle. There are going to be problems with them. You're not going to test effectively. So the idea is that your clear function, which is defined in the spec as erasing the data source, its only job is to literally erase the data source. It's just to reset this back to whatever. So like if my project was just the auth functions and I was to implement clear v1 here, this would literally be as simple as like that. I'm just resetting it. That's it. And that's something that really helps your tests. So HDSQ says, could we create functions and get and set the entire state of the program so that we could pre-fill the state before the test and then restore the state after? You could maybe do that. That sounds fine. Fixtures are more logical though, yeah. The point is not that you have to use fixtures. The point is that when you set up your data, right, like to create a channel, you need users. To even look at channel messages, you need to have created a channel and created users, right? You need to have done those things before. And to do those things before, my point is more just, you don't want to be manually entering data to set that up. You want to be entering data because you've called the interface. If users exist in your data store, it should be because you've called auth register. If channels exist, it should be because you called channels create. It shouldn't be because you manually typed it into a dictionary, because you're making assumptions. Like, that is you trying to make assumptions about the implementation while you're doing the tests, which is not what we've asked you to do. Now, I know some of you are sitting here right now being like, oh God, oh crap, I've like done this slight thing wrong. And I guess I just want to say up front, and you can hate me for it as well, as it's like, I tried my hardest to thread a fine line between, in the first couple of weeks of this course, being very clear on what you have to do, like being like, do these black box tests, write these tests first. We do all of that. But we also know some of you will make mistakes, right? And we also know that in week 1, we could have sat down and been like, we're going to give you the very first test to write, and you're just going to have to copy this for the rest of them. But I don't think that's particularly great education, because I want you to think about why you're doing what you're doing. And when you get new information, I want you to be able to think about why that differs and why that matters. So there will be some of you today that have kind of violated the whole I'm sure there's some of you that have written your implementation before your tests, and maybe you just haven't git committed it. You're like, I'm a genius, I'll just save that in a text file and pretend I haven't written it yet. And that's fine. I'm sure some of you have done that with great effect, and good on you for being devious. But there'll be others of you that have done that, and what it's done is it's made you write tests incorrectly. It's made you do your implementation and then write your tests specific to that implementation, or get caught up in the data source. And that's okay. It's like, we don't expect everyone to follow the rules, and you get tripped up sometimes. And this is the point of this lecture, is to help for people who kind of haven't followed the guidelines, or at least didn't understand them or got confused or whatever. This is meant to be a little bit of a kickstarter back on the right track, where it's like, just try and make sure everything you do, you follow these 2 rules, because I don't want you to get caught up in unit tests and because you can do that, but it's just a bit waffly. It's really simple. Don't manually populate your data store or data stores. Don't access your data store directly in your tests. And then follow the spec, which just says, like, literally if you write your tests before your implementation, you pretty much can't do these 2 things. You actually can't. It's not even possible, which is why we asked you to do it. Which is probably the comment I'll make, because I'll get the email tonight, which will be like, why didn't you tell us this is how to do it before? I did it a different way. And it's like, you did it a different way, probably because you didn't write your tests completely first. There was a great question, though, from Len, which was, how are we able to pass tests if the functions we've implemented are just stubs? If the functions we need to call haven't been completed yet? That's a great question, Len. So it's a question students always ask. They think, how do I write tests? Because if I write tests before my implementation, when I run PyTest, all my PyTests fail. Okay. Well, the thing about that is that's completely normal. That's actually exactly what is meant to happen, because there's no other way to write tests before your implementation without them failing, right? It's just like not even possible. The reason we write tests before we do our implementation, which is what we call test-driven development, is because the second you write implementation, you become biased. You've made decisions about behavior. You've made decisions about processes. Even if you're not writing tests, as a developer, when you're writing code, you're thinking about edge cases. You're thinking about things that could go wrong. So if you write tests after your code, you're going to write worse tests, fundamentally. So that's why you write tests beforehand, and your tests are going to fail. Here's the thing, though. This is like what I would probably say, is like, when your tests fail, they should just fail because like the asserts are not true, right? So you see here how these are all failing because like an assert failed. That's what you should aim for, right? Like all of your asserts should fail. Your PyTest shouldn't fail because there's a syntax error in your PyTest. They should fail because the asserts aren't true because something is not implemented yet. Yeah, there's no way to write tests before implementation without your at least some tests failing, probably most of them. And it's great. Like, I hope some of you get this experience, because I remember the first time I did it. When you write your tests first and then you start coding, and what your coding does is every time you write more code, you run PyTest and you just watch those red Fs turn to green dots. It's an extremely satisfying experience, because you're like, I know I'm doing the right thing. And then last question here. Taylor's exactly right. If your test passed before you do your implementation, you should be concerned. TTTKKK says, if the functions are changing values in the data store, how do you test if it's been put in the data store? So you test if it's been put in the data store by using other parts of the interface. So we did this here, right? We tested if our user has been put in the data store by calling login and seeing if it worked. Right? So you use the interface to your advantage to test these things. I've talked about this for quite a while. I think it's worthwhile that we spent the time on it, but I really would like to move on to coverage, which will take us a little bit. And we'll take a break just before that, but I'll answer this question, which is like, so Len says, so can't merge into master if we're following the spec then? Because don't we have to have your tests and functions pass before you merge it? Yep, so I'll just explain this one more time to people. So it's like, you have master here, and then you say, I'm going to go and implement something. So you write the tests for it. You write all the tests that you think you need. Then after that, you go and write your implementation. And then eventually, after you write your implementation, you'll keep doing this, like in a loop. Eventually, your test will pass. And once your test pass, then you merge this back into master. And meanwhile, your group has probably gone off and done their own things, and like other people are working on stuff. Josh says, but those functions affect other variables. I don't see how you could do something like that for list all, which doesn't change anything. So Josh, I'm going to give you the same answer that I try and give students, because this course is about making people think, which is many things can be tested thoroughly in this course, in this project. Some things can be tested sparsely, as in maybe not as much as you'd like, and some things can't be tested at all. That's the nature of black box testing. You literally can't test everything with black box testing, because some functions don't have return values or obvious side effects that are visible elsewhere. HSDQ just asked a question, which I think, last question, which is like, I'm doing things for message send, and all my tests are failing due to missing functions for channels and users. Just to be clear, so if you're doing things for message send, your tests are failing, not because you're missing the functions for it, but because those functions are yet to be implemented correctly, right? Because those functions are stubbed, therefore they're not missing, but they sure as hell aren't working. So that's normal. So your message send tests, or even your message send implementation, which by the way isn't needed for iteration 1. I know there's probably 100 people freaking out right now. You just don't merge that in until everything else is done. So, okay, I think what I will do is, even though we're halfway through this lecture, I'm actually just gonna poll you, which was like Python testing and project testing. I'm just gonna poll you on this. We'll take a 5-minute break, and then we will keep going with the last part of testing, which is about coverage, which is not relevant for iteration 1. Okay, here you go. So this is testing so far. Let's take a 5-minute break and chat to you at 11:10.